Hi, 6th graders. We're on lesson 110, which starts on page 63 in your textbook. Remember, you can always follow along in your textbook or the online textbook as you are watching and interacting with this video. So 110 is on equations and functions. Our learning target is making function tables and writing equations. So sorry that this is just a tad blurry, but a relationship that assigns exactly one output value for each input value is called a function. So if you think of a function as, a function as kind of like a machine, whatever you put into the machine, then you get something that comes out of it. So every different function is going to have a different function rule. So you put a value in and it does the operation or whatever the rule is, and then you get an output out of it. So let's look at this example down here, and then we'll go back and talk more about our vocab words. Okay, so if Javier saves $20 each month, make a function table to show his savings after 1, 2, 3, and 4 months. Then identify the domain and range. So this is an example of a function table. So let me get this. This right here, not including this input function rule and output, but this is a function table, okay? So you might want to write this into your notes so you have an example of a function table. We're going to be doing another one together in a couple slides. So if you want to just listen and watch, or if you want to write it down, that's fine. Remember, there's a bunch of vocab words that are on your tip chart, so you may want to include those on your chart or at least get those into your notebook as well. Okay, so the input is, so let's go back to our example. He's saving $20 every month. So we want to know after how many certain months does he have, how much money does he have. So after 1 month, we know that he has $20 because he saves $20 every month. After 2 months, we know that it would be 20 plus 20, which is the same as 20 times 2, so he would have $40. After 3 months, we would know then, well, he already has $40. He's going to add 20 more dollars, so he has 60. And then he's going to add 20 more, so he has 80 after 4 months. So we can see that the same thing is happening every time. We can multiply each number by $20. So 1 times 20, we get 20. 2 times 20 to get 40. 3 times 20, we get 60, and so on. So our input is the number of months. Our output is the number of total money that he has after that amount of months. And our function rule is that we are multiplying by 20. So the domain is called the set of input values. So all of the x values, or all the values that we put in, is the domain. So we want to remember that input goes with domain. I'm writing with my mouse again, and that's why it looks sloppy. And then our output is called the range. So it's important to remember the set of values. The values that go in are the domain. The values that come out are the range. And they go hand in hand. So whatever number we put in as the number of months, you are going to get a certain output that goes directly with that input. So if you put 1, okay, if our input is 1 and our function rule then is multiplying by 20, so 20 times whatever number, so we're just going to call it x right now, whatever number, so if our input is x, 20 times 1, our output then is going to be 20. There's no way that it could be 40 or 60 or 80 if we put in 1. If we put in 2, then it's 20 times 2, and we get 40. Okay, so then we would write it this way. This is called a set of values. So with our little brackets our domain is 1, 2, 3, and 4, and the range would be 20, 40, 60, and 80. Most importantly, just remember that domain goes with input, range goes with output. Okay, let's look at another function table. An armadillo sleeps 19 hours each day. Write an equation using two variables to show the relationship between the number of hours H an armadillo sleeps in D days. So we have our table again, okay? So this right here is our table. Okay, if you want to just pay attention and watch, that's fine. If you wanted to write it down, then I would label this as your function table. Okay, so it sleeps 19 hours each day. So we want to know how many hours does he sleep after a certain amount of days. So our input then is going to be the number of days, because we're trying to figure out after how many days, how much is he sleeping. So after 1 day is 19 hours. After 2 days is 38 hours, because he's already slept 19 and we're adding 19 more. 3 days is 57 hours, and you can see that this time we're multiplying by 19. So each number that we're putting in, we're multiplying by 19, and we get our answer. So if we put in D, this is kind of blurry, okay, D days, so after a certain amount of days, we know that whatever number that is, whether it's 10 or 20 or 50 or whatever, we're going to multiply that by 19, because it's 19 hours every day. So then the number of hours, this says 19D. Remember, if you have a number next to a variable, that means multiplication. So that's basically the same as 19 times D. Okay, so we want to write an equation. It says using two variables. Remember, our variables are our letters that stand for our unknown quantity, to show the relationship. So we want to know after how many days, D days, how many hours H will the armadillo have slept. Okay, so we know that the number of hours slept, which is D, equals, or sorry, the number of hours slept would be our total number, equals the number of days, which is D, times 19 hours each day. Okay, so if D is the number of days and H is the number of hours, we know that H, okay, that's our output, will equal 19 times D, okay? So if we write it like this, whatever number, however many number days, we multiply it by 19, we get our total number of hours. How many hours does an armadillo sleep in 4 days? Well, we would take 4, so that's our D, and we would put it into our equation. So as you can see, then they take H equals 19 times 4, so we're replacing D with 4, and we get 76 hours. So it sleeps 76 hours in 4 days. If we want to know after 10 days, we would take 10 times 19, and we would get 190 hours after 10 days. Okay, so our function rule is multiplying by 19. Okay, our input, which is also, remember, our domain, and our output, which is our range. So input is however many number of days, our output is the total number of hours that we've slept. So this is a function. This right here is our function. Our function rule is multiplying by 19. Okay? A botanist discovers that a certain species of bamboo grows 4 inches each hour. So we're going to make a function table, we're going to write an equation, and then we're going to figure out how much has the bamboo grown after 10 hours. So I want you to pause me and try to fill in. So copy this function table. Copy this sentence, actually, so you know the problem that you're working on. Copy this function table and fill it in. these two columns, fill it in, and then see if you can figure out an equation that would go along with this function table. Okay, so if a certain species of bamboo grows 4 inches each hour, we know that after 1 hour, it will have grown 4 inches. We know after 2 hours, it will have grown then 8 inches. And after 3 hours, it will have grown 12, because basically we're adding 4 inches each time. So to get from 1 to 4, and 2 to 8, and 3 to 12, we know that we need to multiply by 4, which I already wrote in there for you. So 1 times 4. And then we would go 2 times 4. And I'm going to start using a dot because we're going to use our x's pretty soon as variables. So it's important to get used to writing multiplication with a dot instead of with an x. So 1 times 4 equals 4, 2 times 4 equals 8, 3 times 4 equals 12. So just because I don't have a number, I'm just going to use h, and it's going to be h times 4. And then when we rewrite, so to simplify this, instead of h times 4, we would just rewrite it as 4h. So we'd always put the number in front of the variable. And whenever there's a number next to a variable, remember that that means multiplication. So our equation, so I just said the number of inches was g, just for growth. So usually we try to think of, or we use variables that go along with what we're talking about. So hours, it makes sense we could use an h. Growth, it makes sense that we could use a g. But it really doesn't matter. You can always use x and y or whatever. As long as your variables go along with the certain quantity and number that you're talking about, it doesn't matter. But we're going to use h and g. So we want to find out the total number of growth after a certain amount of hours. So our equation then is going to be g equals, because that's our total of what we're finding out, and that's our output. Okay, this is our input. Label this on your table. Input, and then label the output. And then just to remind yourself, remember this is domain, because we'll be using the words domain and range a lot more often than input and output. So domain and range. And since you're labeling, this would be called the function rule. Function, oops, that's an N. Function rule. Okay, so G equals, so our output, so our function always starts, or our total then is always going to be the output. So G equals, and then we know that this is our equation. So G equals 4H. How much has the bamboo grown after 10 hours? So it's giving us the number of hours. So we're going to plug that into our equation in for H. So then we have G equals 4 times 10. So then we would say G equals 40 inches. So the bamboo has grown 40 inches after 10 hours. Okay, I know that's a bit confusing. You can always go back and look in your book or just reread. You can go onto the online textbook, and even if you just reread page 63 and 64, that might help you just a little bit. Otherwise, remember to go into NICU and take the 110 NICU quiz. Have a super evening, and I will see you tomorrow.